So welcome back to Security and Privacy in Cloud, and I'm Lavanya, Assistant Professor of CSE Department. So here in Unit 2, the Security Design and Architecture for Cloud, we are going to discuss on the topic encryption and data redaction. So let us see one by one. The first one, data redaction. So what is meant by data redaction? It's a method which is used to protect the sensitive data from being compromised or leaked. And here you would have heard the term redacted information in movies or some classified documentation where some of the information is blacked out. The same principle is applied in the process of data redaction. The second point that they have mentioned, it involves removal of particular pieces of data from the whole of it in an effort to keep it from being exposed as a whole and used for malicious or nefarious purposes. So what is meant by that is here, we can be able to remove some unwanted data from the whole of it from being exposed as a whole and used for malicious activity. Okay, basically here the process just breaks down into various pieces of information and removes or hides the portion that can be used to identify or link or to a particular person or maybe a company or organization. For instance, if you have some credit card information of your customers which is stored in a particular database, you may have to redact. You have to redact the first names of all the card holders or the first and last four digits of the card numbers. In the sense, you can just use this process of data redaction. And the data redaction tools are mainly used by the companies all over the world in order to hide and protect their sensitive data. Not only does it helps in keeping the data source, but also preserves its integrity and authenticity. Okay, as you know, if you want to buy some ATM card, you can just see the first to last four digits will be just shown, whereas the remaining that is 12 digits will be hidden, right? They'll be just showing some crossbar or so they'll be hidden by some digits. Okay, why? In the sense here we'll be using some data redaction. Okay, so that is why we are going for this kind of data redaction method. And can redacted data be restored? So when you redact sensitive data, the specific portion of the information is actually removed to maintain data security. So here, like earlier, people used to add a black box over sensitive information in Microsoft Word files and convert them to PDF. However, this meant that anyone with the access to the Word file would be able to remove the black box and rebuild their information underneath. In more advanced version, like if you take like PDF readers and even Word document, you can't retrieve the one information once it has been redacted. Okay, which makes it more secure than the previous version. So that is why the data redaction is highly effective and is used for protecting sensitive data. So here they have mentioned clearly it is used for protecting some sensitive data, but it also requires you to store your original data properly so that no one can access it. So that is the main advantage of data redaction. And apart from that, here it also requires you to store some original data properly so that no one can able to access it. So the benefits of data redaction is that the first one, data usable. So what is meant by data usable? And second one, compliance. Third one, keep the data secure. So first one, data usable. So at this point, like regardless of which industry you belong, or you need to use some data for your business operation, in the sense you have to go for like this data redaction. Okay, by applying the data redaction policy, you'll be able to desensitive the data, which makes it suitable for use without compromising on security. That's true, of course, unless the data redacted is the data you need, in which the case you should choose some other anonymous options, right? So that is all about data usable. Second one, compliance, like it ensures a compliance. There are several data privacy and security regulations that have been implemented in the previous decade, owing to some an increased number of breaches that are being experienced by companies across the world. By applying some data reduction, companies are able to comply with these kind of regulations. Third one, keep the data secure. So here, this is another benefits of data reduction. Here, it helps you to keep the sensitive data secure. As you may know already, there has been some significant increase in data breach the past few years, and it greatly hurts the credibility of organization. Though the data reduction, these issues can be avoided. Okay, so these are the benefits of data reduction. So there are two types of data reduction. First one static, and second one is that dynamic reduction. So what is meant by static reduction is that it is a predefined fixed process where specific data fields or patterns are consistently redirected based on some set rules. So here it can be used for redirecting some sensitive information from a large amount of requests. It also requires quite a lot of time and resources in order to do so. So that is why this method is useful when you have predictable or unchanging data that needs redacting. So that is the case of static reduction. It is, it will be some fixed. So basic on some specific data you have given already, it will be just redacted. Okay. And apart from that, there are various techniques which is followed in static reduction or in dynamic reduction. So here, but before that, I'll just discuss about the dynamic reduction and then we can go for the what are the techniques available. Okay. So dynamic reduction. So here it involves evaluating data on the fly using more complex logic or scripts. So in you take from data in a real time, that is why like it's known as data in transit reduction. The data doesn't have to go through the batch processing to be redirected. However, it is much suitable for read-only application, and also it has significant performance overhead. Okay, and also it is beneficial for scenarios where redaction rules needs to adapt based on the content or context of the data streaming through the system. So what are the techniques involved? Like you have to protect some sensitive information, right? So there are various techniques which is commonly used. Like the first one is that pattern matching and replacement. So pattern matching and replacement is that we can able to identify sensitive data using some rejects or predefined patterns and replace them with the placeholder text called, for example reductor. Okay. And second technique is that character substitution. We can able to replace the specific characters within a sensitive field with a masking character. Say for example, like in a credit card number, you can just the last 4 digits will be enabled, right? The remaining 12 digits will be masked or will be hidden. So that is called as character substitution. And next one, that data tokenization. We can able to convert the sensitive data into some random tokens which has no exploitable value on their own, and tokens can be mapped back to the original data using a secure tokenization system. And next one, shuffling. We can able to rearrange the data within a data set while keeping the overall data set structure intact. For example, like if you want to swap some data elements within a column of a database to anonymous specific entries, so that is called as shuffling. So within that particular, you know, the day, I mean fields, we can able to we can able to shuffle. Okay. Next one is that nulling out. So completely remove or null out sensitive fields by replacing them with the null values. This erases effectively the content from the data set. And next one is that generalization. So generalization is that we can able to replace the specific data with more general information to maintain some level of usability when protecting some sensitive details. Say, for example, if you want to replace a specific age with an age range, for example, of 34, right? You can write it becomes 30 to 40. So we can generalize the range such that that particular user who's going to hack, he can't able to predict the user, I mean the age of that particular person exactly. The next one is that aggregation. So aggregation, it combines or summarizes the sensitive data to display only aggregate totals or summaries. In that way, the risk of identifying individuals from the data is reduced. And next, last one, pseudonymization. So we can able to replace the identifying fields within a data set with some pseudonyms or some artificial identifiers. So this allows the data to be used in analytics while preserving privacy. Okay. And like what data needs to be redacted, like what kind of data we can able to redact is that like personal information, social security number, passport number, phone number, or some national identification number, Aadhaar number, email address. And next, like financial information, like if you take like credit card numbers, bank account numbers, transaction details, tax identification numbers. We used to call as a TIN number, right? And next, like health information, that it has to be secure most probably in all over the world, like medical record, healthcare provider, insurance policy number, okay? And like credential information like username, password, security questions, cryptographic keys, and token IDs, okay? And corporate information like trade secrets, proprietary business details, confidential agreements and contracts, internal communications such as emails and memos, all those things come under data redaction. Okay. Now let us discuss on the topic of encryption. So this is a commonly used topic which we have seen or we have discussed in the unit 1 also. But in unit 2 they have given again. So we will discuss in detail about the encryption. So the encryption, which is used to protect the data from being stolen, changed, or compromised, and works by scrambling the data into a secret code that can only be unlocked with a unique digital key. Okay. The encryption works by encoding plain text into ciphertext, typically though the use of cryptographic mathematics known as like algorithms. Okay. And also like encrypted data which can be protected on computers or transit between them or while being processed regardless of whether those computers are located on premises or some in some remote cloud service. And Google Cloud offers a variety of ways to encrypt data and protect an organization's cryptographic keys like confidential computing and all those kind of stuff. Okay. So this is all about the encryption. Before going for these types of encryption, we will discuss about the how the encryption works. Okay, so how the encryption works is that by encoding some plain text into ciphertext, and typically through the use of some cryptographic mathematical models like algorithms, we'll be discussing about what are the types of algorithms it is used for encryption. And to decode the data back, we have to use some keys, right? I think you might have heard like public key, private key, secret key, okay, encryption key, decryption key, right? Like like one example is that simple encryption like Caesar cipher. I think you might have like named for Roman Emperor Julius Caesar because he used it in his private correspondence. It's called a substitution cipher where one letter is replaced by the another letter, some fixed number of position down the alphabet. To decrypt the coded text, the recipient needed to know the key of the cipher, such as shifting down the alphabet 4 places and go to the left or left shift 4. Thus, every E becomes a Y and so on, right? So these kind of steps which was used in the historical method. Now let us discuss about the types of encryption. So there are two types. First one symmetric encryption and next one is that asymmetric encryption. So first one symmetric encryption. So here it is also known as a shared key or private key algorithm. It uses some same key for encryption as well as it is used same key it is used for decryption. So symmetric key cipher are considered which is less expensive to produce and do not take a much computing power to encrypt and decrypt. Meaning there is less of delay in decoding the data. The drawback is that if an unauthorized person get their hands on the key, They'll be able to decrypt any messages and data sent between the parties. As such, the transfer of the shared key needs to be encrypted with a different cryptographic key, leading to a cycle of dependency. Okay, so this is all about the symmetric encryption. This is the diagram you could able to see. If I'm passing some plain text, say for example, hello. Okay, if I'm passing like hello in the sense, I'm just writing here. Sorry for the handwriting because it's a little bit tough. Okay, and I'm just passing the word hello. Okay, by means of secret key. So secret key is nothing but some identifier which will be passed here. So this by means of some encryption algorithm, it goes to the ciphertext. So here the ciphertext, it can be like if you are going for substitution cipher, it will be decrypted by means of hash next to 4, the secret key like 4 if you are giving in the sense. By means of 4 characters, it will be real. Next one, say for example, M and then H or something like Z. Okay, based on that it will be passed, and then the secret key which is used in both encryption as well as the same secret key is used for decryption too. Okay, so once you have decrypted, and again you'll be getting the plain text back, that is hello you'll be getting. So this is all about the symmetric encryption. Next one is that asymmetric encryption. So it is also known as public key encryption or public key cryptography, which uses two separate keys. That is, one is used for encryption and another is used for decryption. Okay. So one is a public key which is shared among all the parties for encryption. Anyone who has the public key can able to send an encrypted message, but only the holders of the second private key can able to decrypt that particular message. Okay. So here in asymmetric encryption, it's considered more expensive to produce because it takes more computing power to decrypt, as the public key encryption is often large, between some 1024 and 2048 bits. Okay, so as such, asymmetric encryption is often not suitable for some large packets of data. Okay, if you see the diagrammatic representation of asymmetric encryption, so here also we'll be using the plain text, and here if you are using some public key for encryption in the sense some ciphertext, right? You're able to see here some uh, different keys by means of that ciphertext will be produced. And in this case of decryption side, they have used some secret key or some private key they'll be using. So two different keys will be used and it will be decrypted, and then the original plain text will be produced at the receiver side. Okay. So this is what we call as an asymmetric encryption. So here if you take, so what are the common encryption algorithm is that data encryption standard, a triple DES or 3DES we used to say, and then advanced encryption standard, that is AES, RSA, and elliptic curve cryptography, that is ECC. This RSA is nothing but Rivett Shemet Edelman algorithm. So first one, that is DES, we used to call an encryption standard just developed in the early 1970s. So DES was adapted by the US government in 1977. So the DES key size was only around 56 bits, making it commonly used in today's technology ecosystem. So it was influential in the development of wire cryptography as cryptographers worked to improve upon their theories and build more advanced encryption system. Okay. And second one is that triple DES. So here the next evaluation of data encryption standard took the cipher block of DES and applied it 3 times to each data block, encrypted by encrypting the data, decrypting it, and then encrypting it again. The method increased the key size, making it much harder to decrypt with the brute force attack. However, this triple DES is still considered insecure and has been deprecated by the US National Institute of Standards for all software applications from 2023. And next one is that advanced encryption standards. So advanced encryption standard, the most used encryption method, which is commonly used today. And AES was adopted by the US government in the year 2001, was designed on a principle called a substitution permutation network. That is a block cipher. Okay, there is a stream cipher, block cipher is there actually, which was discussed in the unit one. You can go through that particular basics of cryptography would be there. You can just go through it. So that are the block ciphers which has a 128 bit and it can have keys from around 128. Okay, and another common thing like in AES, we have the two fish concept. So which is used in both the hardware and software. And two fish is considered as the fastest symmetric encryption method. While two fish is free to use, it's not patented or it's not commonly used in all type of encryption application like PGP. There is a pretty good privacy and it can have key sizes up to 256 bits. Okay, and next one is that RSC. So RSC, as I told, it stands for Rivers Shaman Edelman. The trio of researchers from MIT who first described the method in 1977. So RSC is one of the original forms of asymmetric encryption. The public key is created by the factoring of two prime numbers plus and some auxiliary value. For each and every encryption algorithm, there will be some specific formula, right, for both encryption as well as decryption. So based on the formula applied, you can able to just apply that value like key value and the plain text value, and you can apply to that particular level. You'll be getting the result, that is the ciphertext value. Okay, and here also in RSA, the keys will be very large, say like 2048 or 4096 bits will be typical sizes, and this they are considered very expensive and it's slow. So RSA key is often used to encrypt the shared keys of symmetric algorithm. Last but not the least is that elliptic curve cryptography. We used to call as a ECC, an advanced form of asymmetric encryption based on elliptic curves over finite fields. The method provides a robust security of massive encryption keys, but with a smaller and more efficient footprint. For instance, a 256-bit elliptic curve public key should provide comparable security to a 3072-bit RSA public key. So often these kind of, because it's not commonly used ECC, whereas DES and AES, it is commonly used in all over some encryption technique. And here it is used in some digital signatures and to encrypt shared keys in symmetric encryption. Okay. So this is all about the encryption algorithm. Okay. So next topic is that we are going to see about the advantages of encryption. So what are the advantages of encryption is that it protects the data across the devices, ensures data integrity. Third one is that protects digital transformation. And last one, helps them meet compliance requirements. So what is meant by protects data across devices? Here, the data is constantly on the move, right? By it messages between friends and financial transactions. So encryption is paired with security functions like authentication and can help keep data safe when it moves between the devices or servers. In addition to keeping unauthorized people from seeing the plain text of data, here the encryption safeguards the data so that malicious actors cannot use it, commit fraud or extortion, or change the important documents. And third one is that protects the digital transformation. So here protects the digital transformation with more organizations or individuals which uses the cloud storage encryption, and that plays a key role in protecting the data while it is in transit to the cloud, once it at rest on the server and while it's being processed by the workloads. Okay. And last one, helps meet the compliance requirements. Here, many data privacy and security regulations require strong encryption. that includes healthcare data with Health Insurance Portability and Accountability Act, that is HIPAA, and these compliance standards which I have already discussed in the last video, that is GDPR, Gender Data Protection Strategy, and PCI DSS, Payment Card Industry Data Security Standard, and FCPA, Fair Credit Practices Act. Okay, and next one is that drawback of encryption here, ransomware, key management, and then quantum computing. So what is meant by ransomware is that here when encryption is generally used to protect data, right? And malicious actor can sometimes use it to hold the data storage. If an organization is breached or its data is accessed, the actors can encrypt it and hold it ransom until the organization pays to have it released. And second one is that key management. So key management here, the encryption is much less effective. The cryptographic keys that encrypt and decrypt the data are not secure. So malicious actors often concentrate their attacks on obtaining an organization encryption keys. In addition to malicious actors losing encryption keys, such as during some natural disaster like cyclone or whatever may be, here it locks the organization out of important data. This is why a secure key management system is often used by the organization to manage and secure their key. Last but not least, that is the quantum computing here. It poses an existing threat to modern encryption techniques. When it is ready, quantum computing will be able to process massive amount of data in a fraction of time, and as this quantum computing has the potential to break the existing encryption. In the future, all organizations will have to be adapt encryption technique by using quantum encryption techniques. Currently, quantum computing is relatively limited or not yet ready to break modern encryption standard. However, NIST, that is the National Institute of Science Technology, has announced the support for 4 new quantum-resistant algorithms that are designed to withstand the quantum computing attacks. Okay, and if you take like the one of the importance of encryption is that uh, encryption is mainly used for securing, like in smartphone or whatever computer, financial transaction, making deposit or buying an item from an online retailer, say for example Amazon, Flipkart or something. Make sure that they have noticed the website address start with the HTTPS. It is secure. It means the website using the transport encryption. Here, the virtual private network uses encryption to keep data coming and going from a device private from private eyes. So, so the encryption is often mandatory from a regulatory perspective for organizations such as healthcare, education, finance, and banking and retail. Okay. So what are the main important function is that first one confidentiality, and second one integrity, and third one non-repudiation. We used to call as a CIEL. This is a short form you can just remember, which is used in all over the encryption method or the algorithms. CIEL: confidentiality, integrity, authentication, and non-repudiation. Okay. So confidentiality, we know to keep the contents of the data secret, and integrity, it will be verifying the origin of the message or data, and authentication, it will be validating that the content of the message or data has not been altered since it was sent. And non-repudiation, here it prevents the sender of the data or the message from denying they were the origin. Okay, so this is all about the encryption method which is followed. Okay, I hope you may have having a clear idea of the encryption as well as the redaction, data redaction. So thank you all for watching this. Stay tuned for the next video.